Ja, guten Morgen und willkommen zusammen zu Microns Präsentation Revolutionizing the Data Center. Ich möchte mich anschließend und noch zwei Kollegen vorstellen. There's Valentina Arrigoni. You just get up, please, and say the title yourself.
Good morning to everybody. I'm Valentina Arrigoni, Marketing Strategist for Micron Enterprise Business GmbH.
And we also have Jason Edlard.
Guten Morgen, mein Name ist Jason Edlard, ich bin zuständig von der DRAM-Perspektive über unser Business Development und Marketing in Europa.
Ja, und jetzt sind wir schon wieder zurück auf Deutsch. Wir haben uns entschieden, das Intro auf Deutsch zu machen, was selten genug vorkommt, weil meistens amerikanische oder englische Kollegen dabei sind. Mein Name, wie schon erwähnt, ist Andreas Kirschner. Ich bin einer von 3 Geschäftsführern hier für die GmbH. Ich habe noch einen Kollegen. Wir haben 2 Standorte hier in München. Ich selber arbeite von der Leopoldstraße 250 aus. Und wir haben noch einen Kollegen in Neuperlach, der das Design Center für Grafikchips leitet. Und es gibt noch einen Kollegen in den USA, der in der Finanzabteilung sitzt. Wer ist Micron? Wir sind seit 38 Jahren im Speichergeschäft. Wir sind in 18 Ländern vertreten. In 13 der Länder haben wir Herstellungs- und Entwicklungsstätten. Wir sind 30.000 plus Mitarbeiter zurzeit und haben unser Finanzjahr, das von September bis August geht, letztes Finanzjahr 2016 mit 12,4 Milliarden Dollar abgeschlossen. Wenn man sich die Entwicklung kurz anschaut, dann sind wir die ersten 20 Jahre ein reines amerikanisches Halbleiterunternehmen gewesen und haben uns ausschließlich auf Speicherkomponenten fokussiert, in erster Linie DRAM-Speicher. In 1998 wurde dann die Memory Operations von Texas Instruments übernommen und über Nacht wurden wir ein globales Unternehmen. Man kann danach sagen, dass wir alle 3 bis 4 Jahre durch Akquisen und Zukäufe gewachsen sind. Das geht hier mit einer Fabrikwerkstätte los in Virginia von Toshiba, geht weiter mit einem Intel NAND Joint Venture. Wir haben Lexa Media gekauft, wir haben mit Nanya eine Kooperation eingegangen, wir haben Numonyx gekauft, wir haben mit Inotera was abgeschlossen und jetzt 2016 Inotera komplett gekauft. Und die letzte große Akquise war 2013 mit Elpida. Wenn man sich die deutsche GmbH dazu anschaut, dann wurde die deutsche GmbH irgendwo 90 gegründet und wir begannen mit 3 Leuten, einem Prokuristen und 2 amerikanischen Marketingleuten hier in Aschheim in der Nähe von München auf 60 Quadratmetern. Wir sind dann umgezogen innerhalb von Aschheim auf 250 Quadratmeter, waren dann 7 oder 8 Mitarbeiter und ich habe 93 auch bei Micron begonnen. Wir sind in 2006 nach Ismaning umgezogen auf ca. 1000 Quadratmeter und jetzt erst seit 1,5 Jahren sind wir ein Münchner Unternehmen und in der Leopoldstraße haben wir 3000 Quadratmeter und in Neuperlach ca. 1500.
Wie viele Leute seid ihr in München?
Wir sind zwischen 115 und 120. Davon sind 65 circa in der Leopoldstraße und der Rest in Neuperlach. Okay. Ja, unser Hauptquartier ist in Boise, Idaho. Wir haben ein Joint Venture hier mit Intel in Lehigh, Utah. So ungefähr 5 Stunden mit dem Lastwagen weg von Boise. Das ist die Toshiba Fab, die wir gekauft haben. Singapur ist eines unserer größten Hubs, die wir haben für die Herstellung unserer Produkte. Taiwan ist Inotera in erster Linie und Hiroshima, Japan, kam von Elpida. Nachdem wir ca. 20% vom weltweiten Speichermarkt abdecken, würde ich behaupten, dass jeder von Ihnen Micron jeden Tag irgendwo benutzt, weil wir in jedem 5. Gerät irgendwo vertreten sind. Ob das Handhelds sind, ob das Speicher, die in der Cloud sind, ob das Thin and Light ist, ob das Connected Home ist, Green Energy, Tablets. Jede dieser Applikationen benötigt Speicher und benötigt immer mehr Speicher. Jede dieser Applikationen lässt sich auf einem dieser Segmente zuordnen. Es ist ein unglaubliches Wachstum vorausgesagt im Networking-Bereich, im Mobile Client, Cloud, Big Data. Wir sprechen hier schon von Zettabytes. In der Enterprise-Umgebung, Internet of Things, ein Schlagwort, das für viele Sachen benutzt wird. Und natürlich ein großer Bereich, den wir auch hier von München sehr stark betreuen, ist Automotive. Wir haben zum Beispiel weltweit Elektroniklabore, die sich auf Segmente spezialisieren, um unseren Kunden zu helfen, die Designs für die nächsten, die in 3-4 Jahren auf den Markt kommen, ich sage mal sattelfest zu machen, sodass die auch fehlerfrei funktionieren. Vielleicht mal ganz kurz zurück zu der Folie, wo wir auf die Zeitachse geschaut haben. Wir haben angefangen als Komponentenhersteller mit DRAMs, durch Zukäufe haben wir dann NOR dazu bekommen, NAND dazu bekommen und sind jetzt in der Lage, eben auch Lösungen für unsere Kunden anzubieten, unter anderem eben für die Data Centers. Mit der Einführung bin ich soweit durch, and I would like to hand over to Nick because we need to switch back to English now.
Okay, I will switch back to English. Mark and myself don't speak German. And I'll do a quick transition on what Andreas explained you, which is really about our background as an OEM company with a component vendor with OEM markets kind of DNA, moving to an enterprise storage solutions provider today, and talking directly to enterprise end users. I think this slide I'll skip quickly, but you can see that across the various segments that we serve as a memory company, the server markets, the data center markets are where the content per system in terms of flash and DRAM is the highest, and the growth rates in terms of bits is also the highest. So that helps explain why it's so strategic for us as a company. Quickly on that, because you'll see that we'll go deeper in the next section, and Mark will go deeper as well on that. But as regards the SSD market specifically, there are a number of segments within that. So the two most important ones for today are the enterprise and the cloud one. So the cloud, we are thinking about public cloud companies and social media companies, what Gartner would describe as Mode 2 enterprises, basically. And you can see on the slide that there are nuances in terms of the types of SSD platforms that go into those different markets. For example, as you can see, SATA dominant in hyperscale, whereas on the enterprise, traditional enterprise segment, we'll find a different mix of SSD technologies where SAS, for example, is more prevalent. We'll come back on that. So this slide we like because not only are we very proud to work with those companies that are household names, but also because it speaks to our journey from, like I said, a component vendor historically with OEM markets background, all the way to an enterprise storage solutions provider. And we started working with those giant hyperscale companies a few years ago, and it's been a very crucial step in our journey to becoming an enterprise storage partner, because it's been very mind-opening for us as a company. The types of architectures that we discovered working with those guys, and the way they approach building, designing their infrastructure and maintaining it, and methodologies like DevOps and all that stuff, is extremely exciting. And the important point here is that this new paradigm basically is propagating over the broader enterprise market. So what we are trying to do in the market today as an enterprise solutions provider is help companies, traditional enterprises, move from what Gartner would describe as Mode 1 IT to Mode 2 IT, which is basically the new enterprise IT pioneered by those hyperscalers, to simplify a bit. So why go all flash? We're not going to do death by PowerPoint in my section because it's the marketing part. It's about the direction of the market and strategies, and also the voice we are trying to add to the unique voice that we are trying to bring to the enterprise market. So I think you'll find in Mark's section that we'll go much deeper technically, and we'll go through the reasons why these architectures that come from the hyperscalers are becoming prevalent, and the implications in technical terms. But before we do that, because historically, we still are a semiconductor company, and the solutions we bring to market are essentially based on semiconductor technologies, I think it's important to do a quick, to step back a little bit and talk a little bit about the media technologies that we use in those storage solutions. So if you are familiar with the NAND industry, the industry is going through a major transition at the moment from planar NAND to 3D NAND. And why it matters to the enterprise storage markets is because it lowers the TCO of flash-based solutions. And that's a key factor in terms of market trends we will see in the following slides. So basically, we had hit a wall with planar NAND technology in terms of the ability to keep scaling cost per bit and densities of the components. And going 3D, we are basically expanding the path to continuous improvements in terms of cost per bits and densities. We have an excellent 3D technology, 3D TLC. We believe it's a winning technology compared to the competition out there. We've made different architectural choices, which we think provide better reliability at the cell level, and also enable faster productization in the fabs, which is important because it means that our ability to decrease our cost per bit is tied directly to the speed at which we can ramp production in the fabs. So that was for a little bit of background. And now moving into the SSD market dynamics, what we show on this slide is basically a couple of different milestones here, but what's happening right now in the market is that in terms of gigabyte shipped, this is showing gigabyte shipped, SSDs, enterprise SSDs in their different incarnations, so server class or storage class here, are basically outpacing, in terms of gigabyte shipped, mission critical HDDs. So that's a very important milestone for the industry. You see here on the slide that server class SSDs will outpace mission critical shipments, HDD shipments in 2017, and a little bit later for server enterprise class SSDs. But if you add the two lines together, we are already at a point where, yes, please.
Could you tell me what is the share of this 10K, 15K hard disks of the total hard disk market?
Yeah, I don't have this information, but it's a very good question because there are obviously other product categories relevant to the data center and the HDD market, so nearline HDDs and archive type of
and especially
HDDs.
as you say that hyperscalers usually use SATA technologies.
Yeah, that's true. So look, we're not saying that this is the end of HDDs, but probably a better statement. We see that as the start of the end of HDDs, starting by the mission critical product categories. We are not outpacing yet in terms of gigabyte shipped the other classes of HDDs, SATA, high density SATA HDDs, nearline and archive kind of stuff in the data center that we think might come later, and we'll talk to that a little bit as well.
But still the market share of those high performance hard disks would be interesting. Maybe
Yeah. No, it's a very good question. We'll make a note on that. Yeah.
Because I don't think it's very big.
It's a fair point, but I think for the industry, it's nonetheless a very important milestone.
I didn't doubt that.
Yeah. It's just the start, right? The start of the end of HDDs. If you look at the roadmaps of mission critical HDDs, they are being discontinued right now. The products keep shipping, but there is no innovation anymore. And that's because in that market segment, for that type of socket, SSDs are becoming basically...
But there is innovation and slower and...
Correct. There is still innovation in that field.
So I really doubt your theory that you will replace these kind of storage media in the the foreseeable time?
In the foreseeable time, it's a fair statement, but there are innovations coming in the way of QLC, for example, QLC NAND, which is 4 bits per cell, where the industry and ourselves, I think we are in a leading seat in that respect, are working on, for the foreseeable future, I'm not going to give a time frame, but probably 18, 19, 20, very high density SSD platforms to attack more frontally the high density HDD product categories that go into those hyperscale data centers for more like what we call cold data potentially. So that's coming. That's not for the next 2 years, but that's the kind of innovation we are working on as well. Market dynamics, flash array. So on this one, I will tell you, in the past few years, the adoption of flash in the data center has been driven primarily by performance drivers, latency sensitive applications, performance sensitive applications, where flash made sense in terms of removing I/O or latency bottlenecks. What we are hearing today from big enterprise customers, and not only in the US or China, the hyperscalers I showed on the slide, but also in Europe and in Germany, is that the decision, the projects around going all flash in their data centers are driven primarily by OpEx reduction considerations. So it's all about the power savings, the cooling savings, the power infrastructure to cool the data center infrastructure itself. The space reduction, because with flash you can consolidate your server platforms or your storage platforms, so you can do the same thing with less hardware. And maintenance cost as well, because it's universally accepted today in the data center that SSDs are more reliable in terms of AFR and other metrics than HDDs. So in terms of maintenance cost, they cost less. And so that's a big evolution for the industry, moving from a market driven by performance applications to a market driven also. Performance applications are still driving a lot of flash consumption, but also by OpEx reductions considerations. And that's
Excuse me, what was the last figure? You were standing in front of me.
84.
84? Okay, cool.
Yeah. Maintenance costs. I don't know how these numbers have been computed, but we hear customers, including here in Germany, I was with one 2 days ago, who tell us that the case for going all flash because of OpEx reduction is real. They've made, that customer in question had made their own calculations, and they are very interested in basically high density kind of cheap SSDs to rip and replace HDDs in existing platforms, where the need for flash is not performance, but really to reduce the power and cooling budgets, basically, and also maintenance. This is an example. It's a marketing view. I'm not saying that it looks as nice and as conclusive in all examples, but basically here what we are doing is comparing two storage platforms, clusters, supporting a NoSQL database application. One is built with mission-critical HDDs, the other one with SSDs. And the story goes that using SSDs, high-performance SSDs, PCIe stuff here, you can reduce the server count by 60%. And by doing that, you not only reduce your OpEx, but also the CapEx, which is counterintuitive. But what you spend more on SSDs is offset by the cost savings on the rest of the hardware. So the servers, the JBODs, the adapter cards, and all that stuff. And obviously, we don't see the numbers very well here, but there is a big OpEx cost saving as well in the picture. So moving on with the market trends. I don't know if you're familiar with the Mode 1 and Mode 2 concepts of Gartner, but Mode 1 essentially describes the old enterprise IT paradigm, so what has been going on in traditional enterprises for the past decades. And Mode 2 describes what the hyperscalers have pioneered a few years ago, and which is now propagating over to the broader enterprise market. So as a company, we address both modes because the legacy storage vendors, like the big established storage vendors, or some of there is still some innovation in mode 1. There are startups who are bringing to market new kinds of storage arrays. We address that, but more as an OEM company, right? We sell SSDs and components to those guys. Mode 2 is really where we put our money, if you like, in terms of our vision of enterprise IT. We think that this is where the market is going. This is what we've learned working with the hyperscalers. We think that this is really the direction of things, moving to server-side storage, software-defined storage. Some call it hyper-converged storage or hyperscale storage. That, these are buzzwords, but they describe essentially the same thing, which is about bringing the data closer to the compute. And by doing so, removing latency bottlenecks and driving costs out of the data center. So this is mode 2, helping companies move from mode 1 to mode 2 or assist most mode 2 companies scale is really what we are about in terms of the voice, the unique voice we are bringing to the enterprise storage market. And this slide shows also why we are investing so much on server-side storage and the mode 2 paradigm, basically. There might be a debate around the pace of the transition from mode 1 to mode 2, and actually the key concept is bimodal IT. So I think there is an expectation that both both environments are going to coexist in the enterprise. But clearly, the direction of things, if you look at this slide, the orange part is basically the traditional storage systems, your NAS and SAN from established storage vendors. This is a structurally declining market, even though there is a nuance, which is the all-flash storage array market is growing within that, but it's not growing as fast as the server-side storage architectures, whether they are in the hyperscale segment or also in the traditional enterprise space. There are solutions like VMware vSAN or Microsoft Storage Spaces and others, which essentially emulate the types of architectures that the hyperscalers are doing, but more for the traditional enterprise market. So trends, kind of switching gears to the SSD industry level. I'm not going to read through the slide. I think we've talked to the growth rate of enterprise and data center SSDs. We've talked to the transition from SANs to server-based storage. We're not saying it's the end of the SAN, by the way. It's just like going back to the point about HDDs. We are saying it's the start of the end of the SAN. We know that legacy storage solutions will keep existing in the enterprise for many years to come. But the direction of things is clear. SSD TCO, we've talked about it, so that's why I did this kind of little zoom out on the NAND technologies and what it means for the enterprise storage market. NVMe adoption, we haven't talked about it yet. It's a big thing because NVMe is the first interface technology. It's a protocol actually developed from the ground up to use flash on the PCIe bus, at least at the start, in a more efficient way than with legacy disk drive interfaces like SAS or SATA, which, because they come from spindle drives in terms of the background, have more overhead. So that's a big thing. We've released a couple of NVMe SSDs in the past quarter, so we are actively driving the trend. We are part of the NVMe consortium. We are one of the founding members. And another interesting trend here, actually I'll skip to the next slide, re-architecting SSDs as a storage system component for these new architectures. So that's a very interesting trend going on. There are initiatives in the industry like Light NVM or Open Channel SSDs. If you've heard about them, they are about moving some of the control functions of the SSDs outside of the SSD itself at a higher level, basically to the host and the applications. So conceptually, what it is about is reimagining the SSD for those new scale-out server-side storage architectures. thinking about SSDs differently and think that those hyperscale companies like Facebook, for example, they have a very limited set of workloads compared to a traditional enterprise. Sometimes it's only one. Facebook, you can imagine the Facebook app as one application. Whereas in a bank, for example, you will have maybe 5,000 to 10,000 apps, but serving a smaller base of users. So when you are Facebook or those other social media companies, you have one workload, you understand it, at a very deep level. What you want to do is basically give control to your application to manage the NAND in the SSD in a more efficient way, basically. So that's what LightNVM and Open Channel initiatives are about, and they go also hand in hand with NVMe over Fabrics, which has the potential to bring the best of both worlds in terms of the benefits of server-side storage, where you bring the storage closer to the compute, and so you remove latency bottlenecks on the one hand, and the benefits of shared centralized storage on the other hand. We can talk about NVMe over Fabrics in more details in Mark's sections if you are interested. Very quickly on that, it's about the TCO story. NAND cost per bit going down, and consequently, what we are seeing, if you look at the gray part here, flash is starting to expand in the data center for non-latency sensitive, non-performance sensitive, or let's say less performance sensitive applications. At the end of that process, we're talking about using flash for cold storage types of tiers. Within cold storage, there are actually different tiers. There is, a higher tier that we think flash will be able to address, and then there are maybe the very lowest tiers where, people still use tape today. So, to one of the points made earlier, we are not saying that flash will go everywhere, at least for the foreseeable future. That's very correct. Why choose Micron? I think because of the focus, the very strong focus we have on all the different memory semiconductor technologies that can help basically move to that third platform or mode 2 IT. So all the way from DRAM, which Jason here represents in Europe in terms of our product group, to NAND-based solutions with everything in between. Actually, there is a small animation here. There is a lot of innovation going in Micron at the moment around new emerging memory technologies that kind of bridge the gap between NAND and DRAM in terms of the performance characteristics that they have and the non-volatility characteristics. So if you've heard about 3D XPoint, Quantex is our technology brand for the solutions using 3D XPoint that we will bring to market through partners in the next years. So why Micron? Why choose us? Because of that very big investment we are making into developing solutions, memory-based solutions, silicon-based solutions for the third platform of IT or mode 2 IT, and also because of the platform level, architecture level, software level, even expertise that we bring in terms of building systems using the stuff we make that bring the data closer to the compute. And that's the section that Mark will go more in depth and explain you the reasons for doing that and the implications from a technical perspective. And how we do it concretely. So the hyperscalers, they do a lot of stuff themselves. They actually build their own servers. Sometimes they even build their own SSDs. But when we think about how we can help more traditional enterprises adopt those recipes coming from the hyperscale category, customer group, there are solutions today in the market. We all know software-defined storage solutions that are trying to do just that, basically, using the same architectural principles, the same conceptual thinking to bring the data closer to the compute, remove latency bottlenecks, and drive costs out of the data center. So we are partnering up today with a number of software partners and also server partners, because everything that the stuff we make always lives inside a server actually. So we partner up with server vendors and with software vendors to build solutions that can be adopted by more traditional enterprises. These are just examples, and I think they speak volume in terms of our journey from an OEM company to becoming a storage solution provider. That's how we do it concretely. And we've made a big investment in a lab in the US, in Texas, focused on storage software engineering. It's also called our Application Acceleration Engineering Lab. So we have a few dozens of staff there who come from the system industry, you know, the storage system or server industry, with very deep expertise in terms of architecture, in terms of you know, system engineering, who basically work at R&D level on basically tuning the stuff we make for the third platform applications, and maybe also playing with the settings, the trims of those applications to better consume the stuff we make. So it's kind of a circle process.
I mean, there are a lot of vendors who build their new solutions, startups, I have to say, who build their new solutions on the use of SSDs.
Yes.
But they are doing the software because they
Correct.
have the software knowledge and the software experience from
Absolutely right.
many years of working in that area. Will you try to compete with these concerning solutions, or will you see them as as kind of partners, so that you go into these solutions as an OEM or whatever?
Yeah. So it's a very good question. I actually, as part of my role, I cover the Israel region, so I work with a lot of those startups. And when they are pure software-defined storage, when you know they are about creating software and selling software IP licenses, we see them as partners very clearly. And actually, Austin is the place where we bring those startups in this lab to basically work with them in terms of how their software can consume the stuff we make in a better way, and vice versa, like I said. So it's really a partnership, ecosystem enablement approach. And I'm sure some of the startups you have in mind are working with us in that lab. I know for a fact. I won't name some because it's it's like confidential information.
Okay.
But this is really what the lab is about. We are not trying to do what those startups are doing. We're not trying to do that ourselves.
Yeah, it's more complementary than competitive.
Yeah.
So it's more helping them optimize the software stacks for the hardware to take best advantage of it, and that's what the lab's all about.
But you would see, for example, HP with their memristors, they would be clearly competition.
Yeah, so in that particular example, memristor is not a software technology, right? It's one of those new emerging memory technologies.
And it would replace your architecture as a whole?
We don't think so. I will tell you on...
I mean, if it's successful, of course.
Well, but that's the key point, right? So Quantex, which is the technology brand for 3D XPoint in Micron, I will say, there are other emerging memory technologies out there that are trying to basically combine the benefits of NAND and DRAM, right? 3D XPoint is not the only one, but the one defining characteristic of 3D XPoint is that it's far more advanced than any other emerging memory technology in terms of productization. It already exists. We are already making it in our fab in Lehigh, and it's already being sampled to partners, right? So that's the one thing that matters. There are plenty of other emerging memory technologies that exist on PowerPoint or in labs, but whether the economics work in terms of how the technology can solve problems, real problems in the data center at a cost point that makes sense, that's another story. And that's where 3D XPoint and the Quantex solutions that we will bring to market are unique.
And to stopgap until that arrives, then we've obviously got a non-volatile DIMM modules as well. So it's the equivalent speed of a DIMM module, but with a non-volatility as well. So that you can use it in the same way that you would like to use RAM, so for in-memory databases, for instance, but in a non-volatile capacity.
Yeah, and we'll come back to that in Mark's section. I'm going to try to wrap up a bit quicker because I know that the nitty-gritty part is I'm the marketing guy. So I like this slide because what it shows is that what we are about as an enterprise storage provider, storage solution provider, is not only about enterprise IT per se. It goes beyond that. It's about business transformation. One data nugget that I like is 10 years ago, the most valuable companies on the planet were oil companies and banks. Today, the 5 biggest are web-scale companies worldwide. So we're talking about the GAFA plus Alibaba, and there are plenty others. So it's quite fascinating to think that the stuff we make, Micron, is one of the most essential ingredients to the data center constructs of those companies, who are themselves the most valuable companies in the world. So that puts us in a very unique position, and we think that even though Micron is not as well known in the enterprise storage world today as some more legacy established players, we think that we have a lot of legitimacy to be one of those key enterprise storage vendors, and not only one of them, but maybe one of the most influential ones because of where we are coming from at that market. And for a lot of traditional enterprises today, adopting, like banks, telcos, and pharmaceutical, automotive companies, adopting the methods and the architectures of the hyperscalers is not just a nice project to do on the side. It's becoming an existential imperative, because those new web-scale companies that are springing up everywhere are disrupting established business models and industries big time. The best example of that is Uber. What Uber is doing to the car industry, or what Airbnb is doing to the tourism industry. So nobody's safe. And the traditional enterprises, if they want to keep operating for the long term, over the next decades, they need to adapt to that. And that's what our voice in the market is about. We are their trusted advisor to help them move from the mode 1 IT to mode 2, and by doing so, transform their businesses, basically, adapt. Product portfolio, I think I skip, SSD portfolio, except maybe to say that we've announced last week a new enterprise SATA SSD. I think we have a few slides at the end on that. It's our first enterprise SATA SSD based on 3D NAND with TLC. And the fact that it's a SATA SSD, even though there is a lot of buzz around NVMe, SATA is still the lowest cost interface for these drives. And so that means lowest cost interface plus the most competitive NAND technology out there. What it means concretely is the highest SATA SSD on the market, 8 terabytes, and at a cost point that will, we think, push flash into different types of applications in the data center. What we showed earlier about the TCO of flash going down and going into less latency sensitive applications, the 5100 kind of opens up the conversations around that. So we'll come back to it. I skip that.
How much does it cost actually, the 5100?
We haven't published numbers when we launched the product, and I will say we will leave it at that, also because there is a NAND shortage in the market at the moment. It's known, and so it's a bit tricky to anticipate the direction of pricing over the next few months, because there is.
Can you give an idea of context? Because obviously, for these guys, it's really important when they're trying to understand a solution.
Yep.
Because the solution can be amazing. If it's wildly overpriced, it will not go anywhere. If it's terribly cheap, then they want to understand why a company decided to go very cheap. Are they not confident in product? So can we? I understand we can't publish products, but can you give an idea of where it will sit?
Of course.
Compared to other Micron products, but also compared to alternatives that end users might look at, and that they might consider alongside ours.
Okay, fair point. So compared to other Micron products, the 5100 in terms of dollar per gigabyte in the highest density will be the lowest cost product we have for the enterprise space from an SSD perspective. That's really the core of the thinking process behind the product.
So can you repeat that?
Compared to, if you look at the portfolio here, in terms of dollar per gigabyte, for the cloud and enterprise SSDs, The 5100 is the lowest cost per gigabyte of the solutions we offer.
Yeah, can you bring it in any relation to the
You
market?
had a gigabyte price
Yes.
on an earlier slide.
That was for a different solution. But
No.
Maybe
To the market, yeah, it's not complicated. We're not trying to hide anything here. It's just that we cannot disclose hard numbers that are not
No,
official.
but I mean, you could say we are in the range of the competitors.
Yeah,
we are
the
above,
ambition-
10 or
we are
15K.
below.
The ambition is to be market leading. I will go as far as that in terms of cost per gigabyte, right? Maybe to be the
So,
lowest
but
cost per gigabyte
Did
out
you
there.
reach your ambition, or was it just an ambition?
We just launched the product last week, so you know.
So
a
are
bit-
you now with your pricing before the market or not?
Yeah, the answer is yes, clear. The answer is clearly yes.
A concrete question. Are you less than $1 per gigabyte?
Oh yes, of course.
44 cents, you had the pricing.
But it depends what pricing we're talking about. If it's end user pricing or
So
pricing for direct.
if you're actually
customers.
referring to one of the previous slides, the 44 cents per gig that was given on the screen, I believe was for the vSAN solution, and that was actually using one of our older products, and that was including the prices, I believe including the cost of hardware and including the cost of licenses and hardware from Micron.
Yeah.
So that was a cumulative price given for a total solution at a cost per gig.
So you are in fact below 44 cents per gig.
Oh, for a product like that, yes, we can say that. I won't be more specific than that because
No,
you understand
but-
there are so many moving parts, but we think, look, you're asking versus the competition. We have big competitors out there in that market like Samsung and Intel. The ambition is to be market leading in terms of cost competitiveness with that product because of the NAND technology and also because of the density of the SSD. It's the first SATA SSD to market at 8 terabytes per single drive. So in terms of cost per bit, that plays a big part. And there are higher density SSDs shipping today, but more high-end enterprise SSDs with SAS interface. So the thinking process is not exactly the same. Here we are trying to push flash in corners of the data center where flash hasn't gone before, right? It's the first, not the first, but it's an important step in that process where eventually using QLC-based SSDs, we think we will reach the cold data tiers of the data center. And okay, did I skip? And then I'll hand it over to Mark, who Mark, if I can introduce you quickly, is the guy in the teams here in Europe, one of the guys in our teams in Europe who help our enterprise customers design those systems. You know, all the marketing stuff I've explained. How do we do it concretely when we speak to enterprise customers who can be banks, who can be telco companies, who can be service providers? That's the team, Mark's team, who does that concretely in terms of being a trusted advisor and helping them design those systems.
Thanks.
And over to you.
Okay. So yeah, I will attempt to be technical and try and give you as many answers as possible. So as Nick said, my name is Mark Down, Field Systems Engineer here at Micron. My role, generally as Nick just covered on, is going to the end customers and attempting to become a trusted advisor. So when we go to the customers, it's talking about what they're currently doing, listening to them, listening to what technologies and what they're currently using and how they can potentially adapt it into different models. Okay. So really we're talking about the biggest change in computing in 30 years. And I think that's a bold statement to say, but I think it holds true. So personally as well, I came from the old mainframe days. So I actually started my career working on mainframes with Stratus and VOS and the green screen technology. So I'm familiar with the old core memories, RAM packs and various things. Then came the second generation. And what we started seeing is the evolution and the revolution towards desktop computing. And we started seeing desktop PCs come around. And that started spurring the growth of data and the adoption of more and more people having computing, but storing more data. Then came the next, and that was the mobile revolution. So with the mobile revolution, not only are we seeing a massive growth and a burst in the amount of data people are actually gathering and storing, but also we're seeing more expectations from the end users as to how they can access that data within a given period of time and gain more access to data quicker. IDC recognized these, and IDC have put together kind of these 3 platforms. So the first platform being the traditional old platforms that we used to. Some of the banks and financial institutions are still using this. And that is the first platform is the mainframe and terminal. And it's still good, it still has a place. Mainframe and terminals are still good at doing batch processing, sequential linear operation. The second platform is more of the traditional approach that most, I would say, small, medium businesses going up into the large enterprises have taken over the last 20 years, perhaps, maybe 15, 20 years. And that's more as much power as they can either fit into a single server head or a set of server heads acting as a cluster. So if you had a HA failure node set, so 2 nodes accessing the same data, normally you would have JBODs and stack them up, and you'd get more and more data coming off of that. But you're still restricted by the number of heads that can access the data. Then the third platform really changes it. So instead of going scale up and going vertically, scale out, which is the third platform, now enables customers to go horizontally. So to scale beyond just a single rack and a couple of heads with a bunch of JBODs behind it, they can now start scaling out horizontally and putting them both in multiple racks, but also in multiple data centers and multiple continents. So they can actually change the way that they're gathering the data, replicating it, and change the failure domains in which they can use the data as well. You can replicate it over multiple continents now, and people can access it geographically independent of one another. So what we see is that currently about 70% still of the IT budgets are still going into the second platform. And we're seeing about 30% going into the third platform. What we're seeing is a key kind of rate of adoption or a key trend of people attempting to move from the second platform to the third platform. And whether that be whether they've got their R&D departments currently doing tests in the environments and seeing how they can move their applications and stacks into the third platform, or whether it be an active in production and starting to ramp up and scale up now into the production environments. And what we're seeing is that people are attempting to do this through hardware reuse as well. So the hardware they're purchasing for the second platform is again going to be repurposed into the third platform just through a redeployment. So instead of using the traditional scale-up approach and just heads and JBODs, they might be doing the heads with inline storage. So they might be putting the storage actually in the head, and we call it serverification of storage, putting the SSDs in the head itself, and then transitioning that across to a third platform. So moving it to the kind of scale-out technology just by re-imaging the head or moving the existing hardware into a different purpose within the environment. So really it's hardware reuse as well. And this is done, again, through a variety of methods. Some of the kind of common ones that Nick spoke about earlier, we were seeing Ceph solutions out there, we're seeing VMware with vSAN, we're seeing Microsoft storage spaces coming out. So that's kind of an interesting one because it's a hybrid between the two kind of second to third platform, the way that I see it. And people try and correct and categorize various software stacks, and it's often quite hard to do so. VMware and vSAN is actually sitting probably down in the second platform, and then the application stacks are sitting up on the third platform. So where we're seeing Cassandra and Splunk and Cloud Foundry and Pivotal CF, as well as things like Apache coming out now with a variety of new technology to distribute the data across both more servers, but also data centers. And they're starting to do things like in-memory databases so that they can rapidly update transactions, but also grab real-time analytics of the data and the data lakes of data that they're storing. Okay. Talking to Nick's point earlier as well, we are seeing that historically, Flash was used by the rich. Flash was used by the banks or used in specific application tiers where the performance was the key metric. People used to use it in metadata. They used to use it for low latency storage. Then they used to use it as the kind of the tier 1 or the tier 0 caching tiers of SANs and NASes. And it was a limited small amount of memory that they were using. What we're starting to see now is a rapid growth in the acceptance of Flash for all tiers. So we're starting to see people using it not only in the tier 0 and tier 1s kind of applications and workloads. We're seeing that start kind of migrating and filtering down into other areas of the business. So whether it be just for general file serving, whether it be for backups, whether it be for disaster recovery, Now with obviously the latest products we're releasing, like the 5100s, in a 2.5-inch disk, a 7mm, we're doing 8 terabytes. And that is really changing the way in which people are starting to think about what they can do within a given space, how much capacity they can build into it, as well as reducing the U space that they need within the servers and within the data centers themselves. And kind of some of the reasons behind what we're seeing is that the hard drive, for as good as it is, and you made great points earlier, the hard drive isn't dead and it will continue for many, many years. And nobody is trying to say that. But historically, if we look at how hard drives have evolved through time, if we look at an 8 terabyte nearline SAS drive or a 10 terabyte drive, the performance of that drive hasn't changed. So we're still limited by the throughput of the drive, and we're still limited by the number of IOPS that it can deliver. So the technology under the hood has not changed that much. It's still delivering you 150 IOPS, whereas one of our drives, for instance, on the 5100, could be delivering you 75,000 IOPS. So there's a big differential in performance. So not only are we talking about capacity points, we're talking about performance. I think that's one of the key metrics that we're seeing where people are trying to compare now. Should I buy nearline SAS 3.5-inch drives, or should we now look at a different technology and make a compelling argument for reducing the total cost of ownership? And I believe that's a very key metric. There's technological reasons why people are doing it as well. And we can touch on that a little bit more later, but rebuild times. I mean, traditional hardware arrays, when people are creating RAID arrays of drives, if you're talking 8, 10, 12 terabyte drives, the rebuild time of that drive is significant. And it's limited by the number of IOPS it can do and the throughput to the drive. So now it's kind of changing not only at the technological level, but at the application levels as well as to how people are distributing data to make those replication times shorter. Okay. So this is one of the main slides that we go and talk about, and our customers love it. When we actually go and speak to them, they love this, and it makes life a little bit easier for us to kind of try and explain our messaging and why people are looking at doing what they're doing. On the left-hand side, we basically say that accessing a CPU on die cache, so a level 1 cache, takes about 5 nanoseconds. And to make life easier for those non-techies amongst us, we say that we try and normalize that out and say that that is 1 second, okay? On the right-hand side, we say accessing a traditional hybrid array, so fiber channel SAN, accessing it with round-trip time from the application down to the disk and back again, is approximately about 30 milliseconds, okay? And that, we normalize that out in relation to the 5 nanoseconds and say, well, that takes you around 2.5 months to access the data. So going from a CPU to accessing a SAN, there's a significant difference in the delay. The latency of accessing your data is great. Even if you then go to a SAS drive, okay? So putting a SAS drive in the head of the server, we're still bringing it down significantly. And putting it in there, we reduce it to around 6 milliseconds, and it gets approximately 2 weeks, we say, for accessing the data in the head. All-flash arrays, still good, okay? So we're still doing the best of both worlds, your capacity hard drive plus some flash in there and kind of mixing things up a little bit. And we say that's 12 milliseconds. That's still a month. So we've gone from 2.5 months to 1 month to 2 weeks. That's still a long time to be accessing your data. SATA SSDs. So in the head, 300 microseconds, 16 hours. Fast? Not fast? It's relational, right? It depends on your workloads. NVMe SSDs start making a little bit quicker, so we can go to 25 microseconds now, and down to 90 minutes just for accessing the data. But that's still a long way off from accessing the CPU on die caches. Then we get to some of the emerging technologies and where we're aiming to get over the next couple of years. So 3D XPoint, for instance, we're aiming for less than 10 microseconds, is approximately what we've been marketing at the moment. But that's still an equivalent to about 30 minutes-ish accessing the data. And then at the moment, what we're currently selling to customers and they're utilizing within certain environments for application workloads is non-volatile DIMMs. And we touched on that a little bit earlier. So non-volatile DIMMs give you the best of both worlds. So they give you DRAM access speed, but also the non-volatility. So depending on whether you use it in a block or a byte mode, you can either treat it directly as memory, and you can optimize your applications to treat it as a byte access mode, or you can treat it as a block device. So we have some customers altering their workloads for databases so that they can treat it as a logging tier, so transactional logs, so speeding up that. And kind of really the message here is latency is key. For far too many years, people purely focused on the bandwidth and the throughput of the system. But to increase your bandwidth and throughput in the system, you lower your latency. The more you can do within a period of time, the more transactions we can push through, the more bandwidth we can push. And the argument here, though, is we are shifting bottlenecks around the system. By putting more storage in a head, we're then bottlenecking, say, at the network port. And that's where, as an advisor, we'd go in and discuss exactly what they're trying to achieve with the system, how many drives to put in the system to maximize the performance of a node. Let's just build this one out. Historically, again, and talking about the rebuild times, we went to array-based protection at scale. Okay, so the two main categories now that we're talking about, the second, third platform, and mode 1 versus mode 2, is quite easily broken down to say that you either have the array-based protection, and this is the historical model that I certainly grew up with, and quite a lot of people in the room will probably, hopefully, agree with. It was building RAID 5s, RAID 10s, RAID 6, 50s, whatever you wanted to build. And it was the hardware-based protection model, okay? We're starting to see that fade, and that's because of the application now being able to reproduce that data. So when we're looking at the Cassandras and being able to shard data across multiple nodes, okay? Or if we're talking erasure encoding at the object level, people can start distributing the data out amongst the nodes within a cluster, in a data center and across continents again, rather than having to rely on the physical hardware infrastructure to do that for you now. The rebuild times are obviously a big difference then. So instead of having a nearline SAS drive at 10, 12 terabytes, whatever you needed, and trying to rebuild that within the hardware array, now the tolerance level or the redundancy level, the fault domains, are at the application level across all the racks and the data centers. So instead of just having to wait for a rebuild on one particular node, on one particular RAID set, now the rebuild can be done across multiple data centers, or could be as part of the erasure encoding, you could have redundant copies of the data in multiple locations. So instead of just having to wait now for the rebuild times, you can now accelerate that through distributing the data. Does this make sense? So I actually came from a software-defined storage vendor before I came to Micron. So this is kind of relevant to how we used to architect systems as well. And the write buffer versus capacity. So what we're starting to see is that people are trying to accelerate the way that they're writing data to a storage node through utilizing some of the newer technology. Various examples are, for instance, ZFS. Anyone familiar with ZFS, the way it works? But basically you have a write to cache log, which they call a ZIL or a slog. And that's where the transactions or the write acknowledgements will come into. The quicker you can make that go, and the lower the latency of the write acknowledgement, the faster you can move on and deal with the next transactions that are coming in. Other examples, people are wanting to use the write buffers for XFS as a file system and want to use it as a write buffer. So again, we can use this with various technologies such as NVDIMM, 3D Crosspoint, or NVMe SSDs. vSAN, we see it, vSAN already doing it. Some of our recommendations with customers are to do, for instance, one fast NVMe-based drive within a vSAN cluster per node. So it's a cache tier. And then we say, bulk out the rest of the solution with low-cost SATA drives. Because you've got a cache tier, but the rest of it doesn't really matter. So you just need to build a cheaper bulk storage array. Okay. And that's where it really comes down to latency-sensitive applications. So saying that data locality is key. Okay. And vSAN is a good example of that again. The locality of the data, because you're accessing it across the network, the latency in that example isn't so important. Whereas on other solutions, such as the ZFS and the data locality being on a single node, could be incredibly important. So really, these are some of the factors where we go and talk to the end customers and try and understand what their needs are and try and address their needs and match the technology solutions, both in our technological solutions, but also into the software stack of the ecosystems and the partners. Write buffers again. Latency is king. IOPS and throughput is king. But also, people are considering the cost. How much is it costing them both in CapEx but also OpEx. And then we come to the kind of Quantex and how hopefully it will be changing the industry over the next couple of years. 10 times X the performance, that exceptionally high endurance and consistent performance across the actual material itself as well. Capacity, this is really saying the same thing as the latency argument, but quite often capacity has always been about the bandwidth, the amount of data that we can force through a system within a given period of time. And now we're seeing people actually starting to look at not just the latency of how long it takes for a transaction to come to and from that storage tier, but also the quality of service. So how consistently they can get the same level of performance to a tier. So I think that's kind of very important. It's various solutions that we offer, various products at the moment as well, have security in mind. The 5100, for instance, we offer it in 3 security modes. So we have either a non-encrypted model, a self-encrypting model using TCGE Enterprise, so TCG Enterprise as an encryption model, so the ability then to lock SSDs into a single server. So now we're talking about security at, say, corporate espionage levels. So if somebody gained access to your data center, how do you make sure that that SSD is locked to the server so it can't be removed, and then the data read at a different location? We also have FIPS validation. So the SSDs themselves now are validated to certain security levels within the US government for FIPS. Okay? And that's relevant not just in the US, but we're also seeing it as emerging into the European markets as well. So security is also a key concern. And this is part of the Trusted Computing Group specification. So TCGE, and what it means, is that it enables us to not just put a key on a drive, but it's how we manage those keys to make it easier for the end user and the administrators, again, to not just know their data is secure, but how they can manage it and reuse the keys at a later date. Okay. So really, that was all I've got about workloads. I was hoping you guys had some questions about what we're currently doing at Micron and applications and workloads within customers. Does anyone?
But Quantex actually available today?
Sorry, say again?
Quantex is actually available today?
No, Quantex is not. We've got engineering samples of the products.
So the way we will go to market with Quantex is through partners. So obviously Intel is one of those partners, but there are others. We haven't revealed yet who they were, but I think I can say that they are system solutions companies, basically well established in the enterprise space. And because Quantex 3D XPoint is such a new technology, there is a lot of enablement work to do at the controller level and also at the application level to enable applications to consume the new media. So we are not doing it alone. We are driving strategic partnerships with a number of partners. We will come out, and announce more details around the go-to-market plans and solutions roadmaps later I think in 2017. But from a timeline point of view, when those solutions will be available to the market, the message that we give to customers is end of 2018, right? And you might well hear different things from Intel because the IP, the intellectual property around 3D XPoint is shared between the two companies. It's part of the Intel Micron Flash Technologies joint venture. So the media IP is shared, but then the go-to-market plans and the roadmaps are different. We branch out at that stage. So we have different strategies, and I cannot speak to their plans. What I'm saying is...
So just to take to that point as well, so Quantex, if we didn't explain it properly, is the wrapper for the 3D XPoint technology, and it's Micron's encapsulating wrapper, if you'd like, for how we're going to be bringing to market solutions.
Yeah, it's basically a combination of the media, the controller, and the firmware. That's the wrapper for that. We've actually shown at Flash Memory Summit in August a prototype of an NVMe SSD using the controller technology and the media that's coming out of our fabs at the moment. So we've shown that, and there is a lot of stuff on the web on that. If you are curious, you'll find some details. There are two ways to use 3D crosspoint in the enterprise space. One of them is based on memory semantics, we say, and the other one on storage semantics. So basically, storage semantics means addressing the media over the PCIe bus in non-technical words, and using sort of legacy storage. How would you describe that? Commands or
we call it byte or block access. So it's whether it's going to be sitting on the memory systems, or whether it's going to be sat on the PCI buses. And there are two distinct areas in which the technology is being used.
I mean, you have 3D NAND in your 5100 disk. Is this 3D XPoint technology?
No.
And what makes the difference between 3D XPoint and the 3D technology?
Okay, so 3D Crosspoint is not NAND based. 3D Crosspoint is a different type of technology. Okay.
The marketing names can be a bit confusing. We get that comment a lot, so it's
but
a fair
I mean,
point.
so what
it's
is
got
it
nothing
then?
to do. So I'm going to disappoint a bit on that, because the company policy and Intel have the same line. We don't disclose the in terms of material physics what it is. We are
it's obviously it's a 3D technology.
3D, but 3D is becoming a trend to build semiconductors, not only for NAND, but also maybe in the future for DRAM, maybe also for logic IC. So 3D is not completely tied to NAND, if you like. It's a new way of building silicon components, in my understanding of it. So that's why we use the same kind of 3D moniker for both technologies, but they have nothing to do with one another. 3D Crosspoint is not NAND, it's not DRAM, it's something else, it's different material physics. We are just not saying exactly what it is, because it's considered like secret sauce, very confidential. But it's completely different than 3D NAND, nothing to do with it.
Yeah, whereas the 5100 unit is built from 3D NAND technology. Okay, so that is just altering the way in which we're constructing the NAND cells. Instead of doing a 2D planar system, it's actually going like a skyscraper approach and building NAND in an extra dimension.
So this would be, so it would mean that you would, with this 3D XPoint technology, go into the rank of those trying to build completely new 3D basic technology. This is exactly what it is. It's whilst the ordinary 3D NAND is kind of an expansion of classical
so I put it
NAND technology.
I'll put it this way: 3D NAND is evolutionary.
Yes.
3D Crosspoint is revolutionary.
Will you expand 3D NAND to what bit or 5-bit or whatever parallel to 3D XPoint?
So different topics. I'll let you chime in. Regarding quad level cells, yes, we have a roadmap for that from a component perspective. I think it was called out in one of the slides. And we are looking to use that media, that NAND media, in enterprise applications first, interestingly. Typically, we start by consumer applications when we deploy NAND in SSDs. We start by consumer SSDs. Because of the very specific thought process around QLC, we are really targeting enterprise applications around cold storage. So that's a very, very interesting field where we are already working on and engaging in conversations, like long-term conversations with very large customers. It's got the potential to change the industry. I don't think QLC will signal the absolute end of the HDD market, just like tape still exists today, despite the fact that maybe in theory you wouldn't expect it to still exist, but it does. There is a lot of inertia in the enterprise space. So it won't be the absolute end of HDDs, but it will be another step, another very important step on that process of SSDs replacing spindle drives in more and more sockets, basically. Regarding 3D Crosspoint, I don't know, what was the question specifically?
I mean, I just wanted to make a better differentiation between those two technologies than we had before.
I think the latency is the key differentiator.
I would like to know, where are you looking for exactly with that 3D cross-point technology, if you go with the QFC technology, you go for the high-end enterprise stuff.
Yeah, yeah. Okay.
Where then are you going with the other one, and are you not competing with yourself more or less?
I would say if we are you familiar with the latency triangles that we see? Okay, and so we do the tiering methodology. So at the top end of it, you'll end up with DRAM. Okay, DRAM is obviously the
that's what you are going to replace with the...
No, absolutely not. So DRAM will be the top section of the triangle. Okay, and that will be the lowest latency, but also lowest density component that's on offer. Okay, then kind of going through the tiers as we're going down. Under DRAM, we see 3D crosspoint. Under 3D crosspoint, we see NAND. Under NAND, then you have additional technologies still like hard drive or tape or anything else. And it's going through the latency triangle. So really what we're saying is what we expect it to see is an additional tier of memory class technology rather than something replacing one another.
Yeah.
Does that make sense?
So DRAM, 3D crosspoint in terms of latency characteristics is a compromise compared to DRAM. DRAM has superior latency characteristics, so we don't think there will be major cannibalization of one by the other. There might be a bit on the DRAM side. On the NAND side, probably not, just because the cost per bit of going 3D NAND, TLC, and then QLC is going down, surely, but slowly but surely. And the cost economics are not the same at all. So high-level message, we don't think 3D crosspoint will cannibalize any one of the two. Maybe a little bit of DRAM in those kind of in-memory applications, but DRAM has superior performance characteristics. So for a lot of applications, it's still unique, right?
Absolutely. Yeah.
Do we need a new interface for crosspoint?
We haven't actually disclosed what interfaces we're currently working on yet, so it's hard to say at the moment.
I mean, there's a big risk in my eyes that, storage right now, of course it's complicated, but the number of interfaces and, technologies is somehow limited. You have hard disks, you have DRAM, you have flash, you have tape, and you have, of course, different varieties of disk. But if you introduce many more of these storage layers, don't you think that the users will one day say, it's not my problem that you have a new storage technology. Make it usable, make it one interface, and we will use it. I don't want to care about it.
So the way I try and answer those questions really is saying that the technology as a semiconductor is we're like Lego, we're building blocks. So at the bottom, we are a semiconductor, and we build a component. On top of the component, then we can add a controller, and then the interface to it, and then we start building up. And then you get to the OEMs who are integrating into products. Then as you go up the stack, people are adding operating systems and software layers, and how to then kind of use it as an ecosystem. But what we're trying to say is that the underlying technology is one component. So we're saying the NAND or the 3D crosspoint component. Then on top of it, what we're doing is not trying to reinvent the wheel, not trying to add a new protocol, we're just adopting what's currently out there. So for instance, if it's NVMe, if it's SAS, if it's SATA, okay, we're not trying to overcomplicate the market. What we're trying to do is say that we're redesigning the technology from the ground up and then adopting existing protocols and standards and integrating the technology into existing systems.
Okay.
You want to take the 5100 briefly?
Sure.
I've got just a few slides. So that's the product announcement we made last week.
Does this
I think it might be interesting for you just to get some data points on that and the thinking process behind the product, like I was explaining before.
I don't think this deck has it.
Are there still some storage manufacturers committed to crosspoint?
Yeah, you've got it here.
Yeah.
Sorry?
Are there still storage manufacturers committed to crosspoint?
Okay, I'm not going to say any name, right, because I can't. But I will say, without disclosing any name, yes. That's part of the go-to-market plans we have. Is going through partners, and those partners are long-term storage system companies.
Will you be disclosing those names at any point?
Yeah, that's the expectation. Yeah.
Do you have an ETA for the disclosure of the names at the moment?
No. I would say 2017, but it's not in my hands to decide when we announced and what we announced.
Sure. So what we wanted to do is take this opportunity as well, just to briefly go through the new product. So it's going to be a bit more of a speed and feeds plus features of the new 5100 product itself. Obviously, it's a brand new product that we're launching using the first enterprise-grade 3D NAND from us. And really, it's, as we spoke about earlier, it's adopting the existing interface of a SATA interface, so the lowest cost interface out there, and then just adding the capacity now to it. So, as we've talked about earlier, it's the highest density SATA SSD currently available. So it'll be 8 terabytes on a single 2.5-inch drive. And as part of that launch, we're actually introducing as well Flex Pro. And Flex Pro is our new marketing wrapper for the way we're designing firmware. So the Flex Pro firmware itself has two main characteristics that we're going to be talking about, and they're not in that deck. The first characteristic is the flex capacity model, and the second one is our flex security model. So flex capacity enables users to choose the capacity of the drive while altering the endurance and performance characteristics of it. For instance, an example of it would be an 8 terabyte SATA drive. Then on its native configuration, as we'd ship it to an end user, it would be 8 terabytes out of the box and have a 0.6 drive writes per day endurance level. And if the customer wanted to change the endurance level, they can alter the capacity. So for instance, if they wanted to bring that from an 8 to a 4 terabyte, then the endurance would actually double. So the drive writes per day of the drive would jump up to a 1.2 drive write per day. And that's a little bit different from the way we've architected it in the past, and we're giving more of a linear scale into the endurance characteristics. The drives themselves are offered with a 5-year warranty with a total bytes written. So the end users can actually choose the capacity of the drive they require and the endurance level to meet the workload solution.
Can they change that choice during the lifetime?
Yeah.
Absolutely, and that's one of the key marketing messages that we're trying to send out. That if a drive is put into service in one workload, in one particular way, for instance, if you started out life as a 8 terabyte drive with 0.6 drive writes per day, then 3 years down the line and the application workload changes and you've realized that you require higher endurance of the drive, you could then repurpose it to a 4 terabyte drive at 1.2 drive writes per day for the rest of its life. Now we monitor the endurance of the drive itself through the counters and make sure they don't exceed the total bytes written. So obviously as it moves through its life into different workload scenarios, we can still monitor the performance of the drive.
But you wouldn't extend it over 5 years then?
You could. The warranty is 5 years, but it doesn't mean that the SSD dies after 5 years. Depending on how you've used it, you can keep using it just like you can keep using a server.
No, but you don't have any insurance on it.
Absolutely, but in certain situations you might want to start life. Let's flip it on its head and say if you started life with a 4 terabyte version of it. So if it went to 8 terabytes and you've reduced it to 4 terabytes and you've got the endurance characteristics there. As you move through the life cycle of the drive or the workload, so if you've hit your 3-year or your 5-year marker, what you might want to use is just cheap backup tier storage or something that was of bulk but little importance. So if it failed, you didn't mind, okay? But you still have the capacity available of the drive. So you could then turn it from the 4 terabyte back into an 8 terabyte use and still use the drive for a different purpose, a different workload.
Do you see any possibility on the long run to expand the lifetime, the warranty for drives? Because I mean, we're also talking about not making too much waste and so on, and which would the best way to do that would be to prolong the life of each component.
Yeah, so I see it at 2 different levels here. The warranty is not synonymous with the life of the product, right?
No, I know that, but I mean, if you are a company, you want the warranty of the product.
It's something we could consider, but I will tell you, when we work with those hyperscale companies we were talking about, they tell us that the life cycle of those SSDs for them is about 3 years. So they are not asking us to extend the warranty.
No, but I mean, maybe this politics will change to whatever kind of...
From an environmental point of view, I understand. We try to conform to basically what the market expects us to do. which is not necessarily what we are seeing today about extending warranties. It's they take it from a different angle.
Yeah, absolutely. So I think what we generally see as well within the enterprise environment is people wanting a 3 or 5 year warranty given. Yes, from an environmental standpoint, it would be nice if we could extend it and do it, but I just don't think the commercials would stack up for that.
I've heard that Freenet has some temperature issues. Do you think? Is that under control?
Is the question, would there be temperature? I don't believe so, no. So the thermals are tested. This is an enterprise-grade product that we're actually launching. It's been heavily tested in a variety of situations. The drive itself sits within the standard envelopes that you'd expect.
I think our technology, 3D technology, is actually optimized for low power consumption.
Yeah.
It's one of the things that characterize it.
Okay.
So this product here, beyond the speeds and feeds,
Nick,
I like it because it's the thought process behind the product. It's not about highest performance, highest endurance, and whatnot. It's about OPEX reductions. So the FlexPro firmware story around repurposing existing infrastructure for new workloads along the life cycle of the infrastructure, that's part of it. The highest density SSD with the lowest cost interface and the lowest cost NAND technology today, that's a big part of it as well. And so it talks to the slides we showed you earlier about bringing flash to non-latency sensitive applications. And opening up what we call a rip and replace market for SSDs going into existing storage platforms where HDDs are used today. So basically customers replacing HDDs by SSDs in existing platforms.
Okay, I think the other key message we want to leave you with about 5100 as well is qualification cycles. So the 5100 product itself has the same firmware and the same controller across all the range. We do it in 3 kind of main categories. We've got an Eco, a Pro, and the Max, depending on the endurance and performance characteristics you'd like for the drive. So in total, there are 14 SKUs that you could buy a product in. But it's the same firmware and the same controller across all of them with varying endurance. Now, what that means from a kind of a customer's perspective, it means that they could just take one drive and do an internal qualification with it. Then if they needed a different capacity or a different endurance model, what they can do is just to do an internal quick paper qualification, because the physical product is going to be the same. It's just the right characteristics of the drive and the capacity that's going to change. So from a qualification standpoint as well, it's easy for customers to do.
So, but you said you had flex capacity and
flex security. So I touched on it briefly earlier.
Okay.
So the security models is either encryption, no encryption, self-encrypting drive with AES-256 bit encryption on it, with supporting the TCG Enterprise encryption models and security keys, or a FIPS model as well. So that's FIPS validation. So it's FIPS 140-2. Okay. I believe we're also running out of time.
Oh no, you've got 3 minutes.
We've got 3 minutes? Excellent, okay. Any more questions?
Have you guys been briefed by any company that comes to mind as a direct Micron competitor, for example? Just to get an idea, because I'm very aware of the fact that Micron is a $17 billion company. That's massive. I mean, when we got Micron as a client, I was doing a bit of a dance. I've never had such a large client. And yet, you go to people and you say, have you heard of Micron? Not really, not in a storage capacity. And you go like, oh my God. So now that you've seen what Micron is about in the storage space, who comes to mind to you as potential competitors, bearing in mind that you get to speak to a lot of vendors all the time, that they will come to you to tell you about the products? Who would you say?
Samsung, Toshiba.
Yeah?
So they are in the same business as we are, for sure. But I think in terms of the expertise we bring to end users around bringing the data closer to the compute, those new architectures, hopefully we stand out, because that's really a strategic focus for the company. It's bringing that different voice to the market, which Intel can do some of that too, but they take it from a different angle, starting from the CPUs. Whereas one of the stories we showed about server consolidation is not something that server vendors or CPU vendors would educate customers around. So we're taking it from a slightly different angle, and there has been talks in the industry about memory-driven computing, and it means that going forward in those new architectures, memory technologies, whether it's DRAM or NAND or 3D XPoint, are becoming maybe the most essential technology of the whole system. It's not the CPUs anymore. Maybe that's controversial, but I would make the point. It's the memory piece of the construct that becomes the most critical, the cornerstone, basically. So we acknowledge that in the enterprise space, we are not, the Micron brand is not super well known yet, but we think that we are going to become one of the most influential vendors in that space because of the market evolution. I want to add something to that?
No, I think that's good. Okay. All right. Thanks for your time.
Well, thank you very much.
Thank you very much.
Thank you.